In the last few years, wind energy has grown to be a huge economic and environmental business. In 2011 alone, over 3,000 new wind turbines were installed across the United States. This business is creating and maintaining new jobs while also improving the process in which we get electricity. Wind turbines work by turning kinetic energy from the wind into mechanical energy. The wind moves the blades attached to the turbine, which generates electricity. This process is much more environmentally friendly than a coal-powered power plant because less emissions are produced. In reality, no emissions are produced from the actual production of energy, only while making the parts for the wind turbine. Another benefit to wind energy is that it creates energy independence. Today, wind supplies power to more than 11 million homes, and in certain months, wind energy provides up to 6% of America's electricity. One of the issues that wind farms are having is that many people are against them because of the destruction of habitat and impact on wildlife. There are policies in place in certain areas to keep wind energy production out of these certain areas. In addition to the issues with wind farming, there are also many benefits, such as it being locally sourced energy production, similar to that of fracking. This is a benefit to many people because it creates jobs in the United States and decreases our interaction with politically unstable governments.
Texas, North Dakota, and Pennsylvania, community solar gardens have become a trend in the Twin Cities. Solar power is a clean energy source where photovoltaic solar panels actively harness solar rays and have a lifespan of up to 25 years. A key point brought up by J. Drake Hamilton concerning Minnesota's economy is that solar panels are a renewable resource that Minnesotans can produce while fossil fuels are imported. Natural gas has been documented to be about 5.7 cents per kilowatt hour, while solar is about 8 cents. At this moment, solar is not cost competitive with natural gas, but with prices decreasing by large margins every year, solar will be competitive within the end of the decade, without much technological advancement. If there were a price for carbon, then solar would be a great alternative. Both solar and fracking have environmental impacts. PV solar panels use sulfur hexafluoride, a greenhouse gas effect equivalent to 25 times CO2, to clean reactors and silicon production. Also, silica sand mining is a vital ingredient to produce solar panels. However, fracking undoubtedly has a much larger impact. Currently, our state is in support of both, giving subsidies to the solar and fracking industries. The recently implemented solar value tariff is an important step toward a renewable energy future and shows the support of the Minnesotan government.
Hydroelectric power's main environmental problem is that it alters riparian habitats and floods sizable portions of land. Hydroelectric dams can disrupt migration patterns for salmon and other fish. Recent technologies such as fish ladders have been developed to mitigate these effects, however this does not always effectively treat the problem. Like hydroelectric energy, a risk of shale gas extraction is the potential for water pollution, although fracking does not attempt to directly interact with bodies of water. Another environmental issue hydropower energy is criticized for is its ability to cause low dissolved oxygen levels and colder temperatures in water. This alteration of habitat can kill current species who are used to different conditions. Fracking is also seen as a threat to biodiversity. A recent study revealed that there are dozens of indicator species left vulnerable due to deforestation and habitat fragmentation from fracking. Just like fracking, hydropower is a domestic source of energy in the U.S. It generates $9 billion annually, while studies suggest that hydraulic fracturing is saving the U.S. $100 billion in a year when comparing to the use of conventional gas production. The Bureau of Reclamation has stated that hydropower is the most inexpensive source of electricity to produce, despite the high initial investment costs. To explain in a way that is easy to compare the two sources, currently there is enough hydropower being generated to produce the equivalent of 500 million barrels of oil a year, while estimates say fracking produces the equivalent of 14 billion barrels a year.
Geothermal plants use steam piped directly from very hot underground water reservoirs, and this steam is used to turn generator turbines, which create electricity. When the steam cools, it condenses to water and is re-injected back into the ground to be reheated by the earth and then reused. The United States is a global leader in geothermal power generation. 0.04% of U.S. electricity is generated by geothermal plants. Most states cannot utilize geothermal power because the geography does not allow it. California produces 80% of geothermal electricity, and Nevada produces 16%. Nevada saves approximately 4.5 million barrels of oil and 2.25 million tons of CO2 emissions. Geothermal energy is the cleanest of all sources of energy. The water used is recycled and contains no added chemicals. Unlike fracking, which is constantly needing clean water and can contaminate local water supplies. Geothermal plants have almost no carbon emission, while natural gas plants release around 861 pounds per megawatt of energy.
Hydrogen fuel cells are a type of renewable energy that generates electricity through a chemical reaction between hydrogen and oxygen, which creates water as a byproduct. Positive and negative electrodes of hydrogen and oxygen react and are carried through a catalyst called an electrolyte. Fuel cells can be used in an automotive system, such as a car, or a stationary system to power a larger unit, such as a building. Now that you have some background information on fuel cells, we can compare this to fracking. In terms of environmental impact, hydrogen fuel cells are superior to fracking since fuel cells are powered by hydrogen and oxygen. Although we know natural gas involved with fracking is cleaner than coal and oil, hydrogen and oxygen are still cleaner than natural gas. In terms of economics, hydrogen fuel cells are significantly more expensive than fracking. It costs about $30 per kilowatt hour for an automotive fuel cell system and about $1,700 for a stationary fuel cell system. Although both fuel cells and fracking would help the United States gain energy independence from foreign oil and create jobs, fracking is less of an economic cost than fuel cells. Despite the differences in economic costs, fuel cells and fracking are similar in that they lack infrastructure in the United States because they're both fairly new technologies that need additional research and development.